Okay, my outstanding friends, one and all, another exciting day, another shocker du jour. They're starting to come around and they're seeing things in the rocks they cannot explain, and I'm trying to help. So let's see about this tunnels. They're baffling scientists. Strange million-year-old rock tunnels found in Africa. Well, that sparked a bit of interest. So let's see what they're saying, and let's see what we would say as Mudfossil people. Okay, this just came out. Baffling scientists, they found the strange rocks, and these are the rocks. Now, what is it they're looking at? I have some of these little pumped up a little better than this, but we can see there's certainly obvious patterns, and they say they can't understand what could have caused these patterns other than microtubule band of heavily eroded microburrows, and they think some kind of biology created that. Little creatures, apparently. They're saying tiny burrows or small tubes running vertically through the rock in parallel arrangements were found in marble limestone across these areas. It's because it's all the same structure. It doesn't matter what kind of rock it's in, the structure is the key. It depends on how it solidified what it will turn into. Now, we were surprised because these tubes are clearly not the result of a geological process. Now, this is Professor Peschner from Johannes Gutenberg University, and he noticed them while doing geological fieldwork in Namibia. Now, let's see if we can understand what these are. I've got some pretty good shots of this. Let's take an examination of it. I'm pretty sure I know what it is. Let's see. All right, I'm just going to tell you, I think it's a membrane. And here's the deal. You got phospholipids, top and bottom, and in between you've got water hating and water loving. They call them hydrophilic, water attracting, and hydrophobic, water repelling. All right, and in the middle you have all that transfer, just like you can see it. It's basically the same thing. All these little things here and here. Now, above that, you're going to have membranes. You're going to have the basement layer of skin. You're going to have the fluid-filled highway. You're going to have a batch of layers, and down below, you're going to also have a couple of layers, and then you get into the basement skin or organ or whatever it is. It depends on what that was coating. Okay, so what is my opinion about this particular stuff? My opinion is that this right here is a membrane, and that is the upper layer, then there's a lower layer, and then there's other layers of tissue above and below. You see that? That's a layer in its own self. In between here is the phospholipid fluids. And this is the separation zone between the water-loving and the water-hating. All right, you see the different, and they say there's no way for them to account for it other than there must be creatures living down there. No, this was part of a gigantic creature's body, and that is the membrane. That's my claim right now. Let me show you why I can make those assertions. Okay, this is a membrane in a creature like us. It's so tiny you need a very, very good electron microscope to see them. And that's the hydrophilic head. One of them's one doesn't like water and one of them likes water. And you get a separation zone right in between the two of them, just as we saw. So that's why you see a different color there. So you got membrane, you got these little tubules, then you got color changes, and then you got tubules at the top, and then you got another layer. That's just the membrane. Above that, you got all kinds of layers of tissue, which depends on where it is in the body or if it's coating an organ, because everything has a membrane around. Even your muscles, your red blood cells have membranes. Everything has to be coated with a membrane. And through these little holes, they will only allow certain things to come through. That's what a membrane does. And it's all based on the channel proteins. And they have polarities to them, just like the heads of the water heads here. All right, so that's what we're looking when we see that big thing they're saying. Now you would say, Roger, that's just crazy. This here is so thin that you, like I said, if you had that and you held it up in front of you as a sheet, you wouldn't even hardly know it was there because you'd look right through it. Okay, I know this is stunning stuff, but this is the membrane, and I'm going to show you one from a friend of mine, Tyson Carlson, Tyson's Mudfossil Adventures, out on the West Coast. And it is a membrane, and it's quite thick. I'll show you in a second. It has all those channels, very easy to see. All of these little balls are not exactly balls. They're little separations, and then there's glue in between all of them. And that's what I call slurpy, small leucine-rich proteins, leucine, slurpy, gooey membrane stuff, so that it can stay as a mat and float around, but it's impenetrable. The only place you can get through is where it lets stuff come through. That's the whole idea of a membrane. But in between is the hydrophilic and hydrophobic heads with that seam. So I don't really have a measurement on this, but I don't think it's enormous like the one I will show you. But here's the separation zone right here. If you see up the top, you see all those little, that's where the little balls were. And then coming down with the little filaments. They bang heads here, down here. The ones at the bottom you can't see as well because they filled in. But the ones at the top have sort of emptied out where the phospholipid membrane was. Above that you have a fluid-filled highway. You have the basement skin above, or whatever it was attached to. Body, muscle fibers, whatever it is. And down here you have a whole nother set of circumstances where the skin is literally attached. That's flaking off basically like skin. I have this stuff all over the place here. I got tons of that kind of stuff where the flakes are coming off. And this, I don't know what that membrane was, but I'm 100% sure that's a membrane. And like I said, I don't know how big this is, but I'll show you the one I do know that Tyson had. Look at this puppy. That's all those balls. They're not all round like that, but they do have these seams. You see the seams going all around? Every one of them has that. And what happened was there was glue on here. Just the whole thing was matted with like a mucus, gluey mucus, which sealed this. And the whole thing can move around in all kinds of elegant ways, but stay attached through these little divots here. And right at the top of these little heads, on the top layer, which is up here, you see that's 6 feet above. This is a 6-foot layer. This is only the bottom. This is only the bottom. And these are those protein channels. They're all over the place, just as they are in the one that they talk about, little tiny burrows. These things here, they sit down in here and they have campfires in there and sit around on these stumps. This is big. This is full size. This baby, it is what it is. And even this little squirrely thing, this blue thing here, that's in the other one. You see, there's one here too. I don't know what it does, to be perfectly honest, but it's in the anatomical thing here, that little squirrely blue thing coming out. And it's the same. It is the same. There's no difference whatsoever. It's identical. And it's anatomically correct, whereas this is just a sketch. This is truly on the edge of the ocean. And it's just wearing away and exposing the two layers 6 feet apart. So this is a 6-foot layer. In us, you would hold that layer up, take that whole thing, drape it down, and you could put it in as a window almost. It would just be, you could basically see through it. And this is 6 feet thick. I don't think you'd see too well through that. Well, this just goes beyond cool. I was showing this heart, which it's a heart, and it's all iron banded and cracked from iron banding, which means there's black and red blood, the vein and artery blood together in two little buckets in here. Because it was laying flat like this, the layer of red and layer of black, they're layered and layered and layered. It's called iron banding. And they just oppose each other so hard that the black pushes and fractures and the red gets in the middle between the two layers of black. Okay, you see the black? Well, in between every one of these cracks is red in between the two layers of black. And the black just cracks everything up. Now, so I've been showing this for a long time. Where do you see this? I can't even believe it. Watch this. All right, in a normal heart, you have the iron banding. You see the red and the blue next to each other? They hate each other and they push each other apart, and the whole top pops right off. You see the red and the blue, it surrounds the whole top and it just pops right off. I'm serious. When they do autopsies, the thing just falls right off of there. And in space and everywhere else where there's hearts, and which there are, I mean, I can't help it. They're there. The plumbing pops right off the top. You see this? This is, where is it, Psyche and so forth. Well, never mind. All right, I showed you the iron banding. Look at this. This is another one, flat as a pancake on the back. Now, this I believe was a liver. I'm not sure though. But anyway, my point being is this has iron banding. You wouldn't believe it. There's the red blood. There's the black blood. It broke right on that line. I didn't cut that. That broke right like that by itself. That's the iron banding here. There's the red blood. There's the black blood. And it must have been sitting like this. Wait till I show you the next one. It's going to blow you right out of your socks. All right, so this one here must have been sitting like that. The black blood went down, the red blood stayed over the top. Now, I have another one here, and that again is the red blood and the black blood separating because they push away from each other. Now, wait till you see this. All right, the next video is going to be about this giant toe. Oh man, it's heavy. This is the callus. That's literally the callus that's on the side of the guy's toe. You see it? That's the bottom of the toe. These are all what they call plagioclases, those little white things. That's that nubbin on the bottom of your toe. You got one of those too, really tough spot. That is a callus. This is what's called cornified skin. That's where the toenail was. There's a big toe. And this side is where all of the vein blood blew out, the black stuff. From this vein entry here. And the reason it blew out here instead of where the red is because of this patch. That's literally a patch on top of where the artery is. That should have blown out this side. This is the first time I've ever seen anything quite so spectacular. And it blew off the the toenail. And this is down into where the blood is. We can look at this in a microscope. It'll be really interesting to see all the different blood and so forth. Because this thing died, almost no question, in that mode like this. And all the blood came down this way and collected. That's that scuffy stuff in between your big toe and your next toe over the floppy skin. And there's the outside of the toe, and it's a serious callus. Now I'm thinking of I got a little jackhammer, a little small jackhammer. I was thinking of trying to pop that off. This has to be saturated. Well, I know it is saturated with metals because I can see them. I've looked at them in a microscope. And that's what happens, is that all the metals in the blood seep down and they will collect in there. And I know it's saturated with metals. I'm just thinking about popping it off and see. Oh, doing a callusectomy on it. But the next one, we'll see what it looks like in the microscope. You see, that's blood just bubbling out of there. The blood was running down this way and had nowhere to go. So it popped out of here and out of here. Now, normally it doesn't do that. Normally it blows out through the side. That's where artery's supposed to go. That was the artery side here. And that's the artery blowing out the end. Now, this is a fingertip, extremely eroded. That's the two veins. They seal off. They have clamps to seal them off from going backwards. And the same thing here. That one's sealed off. The arteries don't seal off. That's artery, artery, artery. And there's the artery coming in, and there's the vein. The tube is still in the vein. All right, that, if you know what to look at, that's what they call a distal phalanges bone pattern. That black, maybe they can't see it, hopefully you can. And this, actually, the bone was right here. If you can see that, it comes up right around here. These are tendons that lock into the bone. Those little bits and pieces, extremely eroded. I have another one from that same creature's hand. There's a huge, huge hand. Some of it's extremely eroded, some of it's almost like perfect. And this one is on the extremely eroded side, but it should be about this size. Hold on. I have one here. Here it is. This is supposed to be the size it is if it didn't erode. This is it now, completely eroded down to. This is what it should be, this size here. The reason I have this on is to keep this tendon held on here. The bone is right here, and the tendon I snapped off. And the bone you can still see in there. And that's the bottom of the fingerprint. This is DNA tested, human. That's DNA tested, human. And another one bigger than this is DNA tested, human. And you can get right down into blood. Once you get into there, you're into some serious amount of blood. So I guess the next thing will be to, oops, I hope you could hear me. I didn't have my microphone on. I guess the next thing will be, we're going to be doing this. And I'm still debating about pulling off that callus. I think it'd be fun. Okay, I'm going to make you a heart surgeon. You got a big bag of red blood. And then you got tubing. All right, now, and then you're going to have some serum too. Now, let's see what happened with Phil's heart. My friend Phil Harris found this heart here. This is the top of the heart. Tubing. There's the big bag of red blood, but this is the black part. All right, the red stayed below, and I'll show you. And that's the serum, and that's those plumbing parts I just showed you, the valves. Now, wait till you see this. And again, it broke right off. He just tapped it, and it broke right in half. And they break on that seam, the same seam as all of them. Look at this. That's what was on the other side. It was just solid red blood. He saw this, and the whole thing was complete. And he just tapped it, I think like here with the hammer, pop, and it just popped right open. Here's the red blood has settled down or up, and it's one or the other. And the plumbing came right off. They all have that seam running around them, and when you whack it, they split right on that seam. Isn't that fabulous? Look at that. There's one side of the heart, the bucket side, and this is the plumbing side. You see it? So it's just outrageous. Totally outrageous. Totally. And unfortunately, Phil passed. And but and this was a 15-minute challenge. I had put out a thing for a 15-minute challenge. They said, you go out and look around, and within 15 minutes, you're going to find something you can identify as a body part. 15 minutes he found this. Plus he found some other stuff. He found a bunch of stuff. And I had other people find even more spectacular stuff than that. This is about as spectacular as it gets, though. Because right off the top is this here. That's where the black separated from the red. And that's where the plumbing was. It's stunning. Okay, I'm going to show you one last thing. I have new species, and stuff I have is DNA tested, 3 of them. This is one of them, and 2 of them are from giants, absolutely enormous giants. And they all had this flat, like a pancake on one side from dying in the Great Flood. And they boiled off all the fleshy stuff and left the fascia-facilitated fossilization, which is what I originally called it. I call them now mud fossils because the mud was the preservative. Mud is just like flesh. When this thing died, it didn't even know it was dead. It was still surrounded by mud, which is flesh. And basically all this stuff. Now, and there was giants here all over the place. I'm going to do an autopsy of a giant toe, which is a big toe, and it has a callus on it about that thick. And you can't miss it.